Hi everyone. So in today's series of videos we're going to be talking about the chapter of redox reactions. Now in the multiple coming videos we'll be seeing how redox reaction occurs simultaneously, and there's one more topic which is the oxidation number, which often troubles us. So we'll see how to understand the idea of oxidation number as well. So we'll be talking about redox reactions. But before coming to the idea of redox reaction, let's talk about the idea of reaction in itself. A reaction is basically when an element combines with some other element and makes a new product. This is generally how a chemical reaction. And to understand this even better, we should know that there are two kinds of elements: the metallic ones, which are in group number 1, 2, and 3 of the periodic table, and there's a series of non-metallic elements, or also known as the non-metals, non-metallic elements, which are in the group number 4, 5, 6, and obviously 7. Group 8 is generally noble gases, so they seldom partake of any chemical reaction because they have a complete shell. Why would they participate, Coming back to metals, for example, I'm talking about sodium. So for instance, I'm talking about sodium as a metal. Sodium has its own nucleus, its own series of shells and everything. So these are the shells of sodium, for example, hypothetically, and this is the nucleus of sodium, let's suppose. So let's suppose sodium is like, okay, it has multiple electrons in its shell. It has this entire configuration. For example, it has 2 electrons in the first shell, then 8 electrons in the second shell, and 1 electron in the last shell. Whenever sodium as an element, I'm talking about sodium atom, wants to react, it always loses the electron because that's the only option that metals react with. So sodium will do a very simple thing. Sodium will keep the other part of the system intact, but the last electron will be lost. So sodium will lose this last electron, and now it becomes a plus charge. So now it's not an atom anymore, it becomes a charge. It is a sodium ion. So metals always react by losing electrons, and non-metals always do the opposite. So let's suppose, for example, I'm talking about a non-metal. For example, I'm talking about oxygen, let's say. So oxygen was like, okay, oxygen has its own nucleus. Then oxygen is like, okay, it has a shell around it. So oxygen had 2 electrons in the first shell. Let's use some other shape. 2 electrons in the first shell and 6 electrons in the second shell. And oxygen was like, okay, I want to react. So oxygen was going to react always by gaining electrons because this is how all the non-metals do it. So oxygen will do the exact same thing. Being a non-metal, it will gain electrons. So it has gained electrons. It needed 2 electrons to complete the valence shell. So it gains 2 electrons to complete the valence shell. It becomes a minus charge. So previously it was a simple oxygen atom. Let's suppose it was an oxygen atom. We never have oxygen in a simple atomic form. It's always a pair of oxygen atom. But considering, let's suppose it's a simple atom. Now it's not an atom anymore. It's a -2 ion. So metals always lose electrons and non-metals always gain electrons, and losing electron is known as oxidation. So when any element, particularly a metal, loses an electron, it's oxidation. And when obviously a non-metal gains an electron, it is the opposite, known as reduction. So one thing is very clear so far, that redox reaction means two things. It means a metal, which was an atom obviously in the beginning, reacting with a non-metal perhaps, and they make their own products. So by the end of the day, a metal becomes a plus charge, whatever plus, maybe it +1, +2, +3, depending on how many electrons we are getting rid of, and non-metal always becomes a negative charge. So this part of the equation, this half part of the equation where the metal is becoming a positive charge, it is actually a loss of electrons. So loss of electron, and that is known as oxidation. You can see one more thing, that a metal was initially a simple atom. It had no charge on it, so technically the charge was 0. Now the charge is increasing, so the charge increases as well. It was initially a 0, but by the end of the reaction it's a plus charge. What the non-metals do is, it's totally opposite obviously. The non-metals gain electron, so non-metals gain electron, that is known as reduction. And you can see one more thing, that the non-metal was initially a 0 because it had no charge on it, it was a simple atom. But by the end of the day, it has a charge on it, which is a negative charge, so the charge is technically decreasing. Charge decreases. So the metals always lose electrons, which is oxidation. Non-metals gain electron, which is reduction. One more thing is also important, that the charge also changes. So far we are done with two things. We know there's a concept of oxidation, and we know there's a concept of reduction. Oxidation means loss of electrons, increase in the positivity of the charge, so increase in charge. In the upcoming video we'll be using another word for charges, but so far let's keep it charges to make it simple, you know. So loss of electrons, increase in charge. Non-metals, what they do is they gain electrons, so gain of electrons is reduction, gain of electrons. And also one more thing is decrease in charge, so the charge becomes more and more negative, because when the electrons come they bring negative charge with them, so it's a decrease in charge. So far redox reaction is a combination of two things: oxidation, loss of electron, which is generally done by the metals. Reduction is the gain of electrons, which is generally done by the non-metallic elements. Oxidation always brings a positivity in the charge. The atom always becomes more and more positive with a +1, +2, +3. Non-metals, which when they do reduction, they obviously become more and more negative.